Hello everybody and welcome back. Root Beer here with question number 24 on the 2017 Cayley contest. Okay, so hopefully you've tried this one and we'll try and take a look at it together now. Alright, 3 coins are placed in the first 3 of 6 squares as shown. A move consisting of moving one coin one space to the right, consists of moving one coin one space to the right, assuming that this space is empty. No coin can jump over another coin, so the order of the coins will never change. I seem to recall a Galois question maybe a decade ago that had to do with coins moving and jumping. So maybe there's a connection to that or something. How many different sequences of moves can be used to move the 3 coins from the first 3 squares to the last 3 squares? Okay. So that's the goal. And we've got some options here, 44, 40, 42. So we should be expecting something in the 40s, maybe 50. Alright, so I'm going to say that writing out all the possibilities is going to be very challenging unless we find just the right methodical way to do it. Maybe, but first we'd need to figure out how do we represent the appropriate sequence of moves, probably with the letters that they've got, and then enumerating them all in a meaningful way so that we get 44, but make sure that we haven't missed enough that it becomes 50 or something like that. Or make sure that we don't think it's 42 when really it's 40 and we've double counted. So that's going to be a challenge, and I don't think we're probably meant to enumerate them all. Which means, if we're not going to be writing them all out in a particular fashion, what could we do? Well, we sort of have, I feel a little stuck here, so we sort of have 2 options, I would say. Either look at a smaller case, and I'm probably not going to draw the circles, I'll just have, X, Y, and then we want to move it down to X, Y, and this is just very basic, 2 in the front, 2 in the back. Maybe the number 3 is special, and so it should be extended this way. I'm not entirely sure, but we could look at a simpler case like this. Alternatively, we could just try and, I'm not going to draw the boxes. Let's 1, 2, 3, 4, 5, 6, X, Y, and Z. All right, so they can't jump over each other. So Z has to move first. There's no doubt about that. And then, well, there's lots of, we could move Z again, or we could now move Y. So I'm thinking maybe a tree diagram might be in order, because we have choices now. So that's something to think about. We have choices. Let's move Y, just for fun, just to try and understand the puzzle a bit more. And let's move Z again, because I don't want to be predictable and just keep moving X. I'll remove Y. I'll move Y again, and let's start moving X. So this is just one possible way to do it. At worst, my choices are move X, move Y, and move Z, but I'm noticing that most of the time I'm just moving either X has a space or Z has a space. The only time that each guy could move forward was sort of this situation right here. So if I were to have a tree diagram, most branches would just be 1 or 2 things that we could do. So it might not be that bad. And then we can... I guess we're sort of stuck here. It's got to be Z, and then Y, and then finally X moves into position. Okay, so that took 1, 2, 3, 4, 5, 6, 7, 8, 9 moves. Should there be any variation in the moves? Well, no, because Z has to move 3 spaces forward. It's going to happen at some point, but Z will only move 3 spaces. Y will only move 3 spaces. X will only move 3 spaces. So yeah, it should be a total of 9 moves in overall. So I'm thinking maybe just a tree diagram. So we have to start by moving Z. And we'll have X, Y, Z. And then we could either move Z again or move Y again. If we move Z again, we get X, Y, and then Z's blank again. So then again we can move Z or Y, and then that'll be the last time we move Z. Then we'll be forced to move Y. But I'm having to, in order to figure out what my next moves are, I'm sort of having to. This one will be X blank, Y, Z blank blank. So then I can only move X and Z. And I'm starting to notice this might not be the best way to do this. That's okay. I imagine if I had a big enough sheet of paper and I really couldn't think of another way to do this question, this would probably work out. I'd get all the answers. Because, think about it, there's only going to be, at most 50 of these branches. As long as we are keeping track of everything, yeah, we could probably write it all out. But I imagine, it's question 24. I don't imagine it's just a exhaust yourself style question. So let's think about this a bit more. We have to move Z first. And then it's a choice of do we move Z or do we move Y. So one thing I'm noticing is, I sort of have, on each branch, it's sort of a list of instructions. So these sets of instructions would start Z, Z, Y. And then, maybe it'll go to X, or maybe it'll go to Y, or maybe it'll go to Z. As a matter of fact, this one is now the X, Y, Z. This is the only one where I'm going to be able to move all 3. But then, we've got another branch tells a different story. So maybe instead of thinking about branches, we think about these lists of instructions that we could construct. Is there a nice, clean way to enumerate the list of instructions? First of all, can I tell whether or not something is a list of instructions? Because if I just start listing letters, if I have anything that starts with like X, I can't move the X coin first. So there's obviously some sort of structure to the words, and that's just a term for any sequence of letters. But there's got to be some sort of structure to the words, and maybe that's what I'm supposed to tease out of the question. So Z will always be the first one. So we're going to start with Z. And then we have the choice of Y or Z. This keeps sort of coming back to the tree diagram, so maybe I'm just going to have to bite the bullet and do that. But then we have the option of Y or Z. Now, if I have a word, and it's going to be 9 letters, and it's something like Z, Z, Y. I don't even know if this one works, but every time I see Z, that's the command to I just moved Z. So Z will only appear 3 times. So each letter will only appear in a set of instructions 3 times. So I'm really counting the set of sort of valid instructions, and right now I'm trying to understand how are these instructions put together. So Z moves first, that's why we have to start with Z. And then you can't follow it up with a X because Y is in the way, because Y hasn't moved out of the way. And the only time you can move X is if Y has moved out of its way. So I think number of Y's read from left to right must always be greater than or equal to the number of X's. I don't think I'm expressing this right. What I want to say is if I stop at any point in the word, the number of Y's should be greater than or equal to the number of X's. Yeah. No, actually, I think that was fine. So maybe saying reading the first K letters from left to right, the number of Z's must be greater than or equal to the number of Y's, which must be greater than or equal to the number of X's. Right? Otherwise, you've asked for too many Y moves, and he's going to run into, too many X moves, and he's going to run into Y. And is that it? Just 3 appearances of each of these, and at any point that I chop it off at any sort of prefix. That's too many Z's. We need a Y, don't we? Well, it can't end at Y. It has to end at X, because X is the last guy has to move into position. Right? Because if Y is just moving into position, then Y must have been here, and then Y moves down here. But X would need to be here already, so, but, if I chop this at any point, number of Z's is 2, greater than or equal to the number of Y's, greater than or equal to the number of X's. If I were to chop it here, number of Z's greater than or equal to the number of Y's, greater than or equal to the number of X's. Yeah, it all works out up until here, I think. Because now we've got 3 X's, 2 Y's, and 3 Z's. So, 3 Z's, 2 Y's, 3 X's. This is not a valid set of instructions. I can't help but wonder if I would have been finished the tree diagram by now. Just absolute sheer determination going through the tree diagram. Might have been done by now. But there's also can we understand this question at a mathematical level and sort of try and pull together and use this sort of thing in a future question. So let's look at this. I don't mind looking at this for an extra 10 minutes if I have a really nice mathematical technique that can apply in the future. Alright, so this is what characterizes the sets of instructions. We need 3 Z's, 3 Y's, and 3 X's overall, and the first K letters from the read from left to right must always have the number of Z's greater than or equal to the number of Y's, greater than or equal to the number of X's. Okay, so we want to count those strings of 9 letters that are valid instructions. How can we do that? I don't think it's as simple as, choose these 3 to be the Z's and then these 3 to be the X's and so on. Especially because we know the last thing has to be an X and the first thing has to be a Z. But what I'm thinking maybe is recursion. And I'm thinking this because I've seen, and I really wish I could remember what it is. I once saw a question involving binary strings, and it had 0s and 1s. And basically you were instructed to make the string longer, and if you saw a 1 as your last digit, you did this. And if you saw a 0 as your last digit, you did this. And so depending on what you chose to add on, you would be adding certain... It turned out to be a Fibonacci sequence question, but that's the reason why I'm thinking maybe some sort of recursion. So maybe I can't jump to 9 letters all in a row for my set of instructions. But maybe I can build it up. So, let's let I don't know, let I for instructions, and then I don't want to use 3 subscripts here, but let I don't know, we'll turn it into a function. I think that looks a little better than I sub z, y, and x, but so this is just going to be a function, and it's going to be the number of valid instructions with z many z's, y many y's, and x many x's. Okay. So ultimately my goal is figure out I333. I know for a fact that I100, there's one way to just have Z be listed. It's just going to be Z. And there's going to be no valid instructions that start with Y. And no valid instructions that start with X. Now, how do these things get put together? So, if alright, so here's what I want to do. I want to say IZYX is equal to, so it's going to be some number of, I'm going to have something like this. This is sort of my basic template. And then z minus 1 yx. So I don't think this is quite correct. But basically, if I want ZZs, YYs, and XXs, can I add on, so this amounts to adding on an X, which I don't think we can always do. This is adding on a Y. Again, I don't think I can always do it. And this is adding on a Z. I can always move Z forward. Until Z hits the end, I can always move Z. But the question is, can I always add on a Y? And the answer is no. I can't move Y if Y minus 1 is equal to Z. And I can't move X if X minus 1 is equal to Y. I think that's... so those would be 0, I think. So I of Z, Y, X is 0 if Z is less than Y, or Y is less than X, or Z is less than X. Is this one already... Yeah, if Z is less than X, one of the other two has to be true, but that doesn't really matter in the long run. Okay. So, I want to sort of keep a running tally, but I don't think it's going to be easy as the binary question that I remember. So, I333 is going to be I332 plus I323 plus I233. But of course, these ones are 0. And that's why it always has to end in an X, so that'll be the same number. I don't think expanding backwards is going to help. I think it's going to be just as bad as trying to do a tree diagram, and it's going to be messy. Can I figure out something else to do? If I had a chart, a table of values with my z's, my y's, and my x's, I don't think I can properly express this. Okay, let's let z equal 0. And then my x's and my y's like this. But of course, this is just going to be a chart, and this we'd have I of x, y, and z. Or sorry, z, y, and x. I forgot the order that we do this in. But those are all going to be nothing because we've got z is equal to... z needs to be equal to 1, and if z was equal to 0, then that would be... the chart wouldn't fill because it would be just full of 0. So no point in having that. So y could be 0, 1, and x could be 0 and 1. Okay. So if they're both zeros, then 1, 0, 0 is just, there's one way to do that. I of 1, 1, 0, there's one way to do that. You add on the y after the z. And 1, 0, 1, there's no way to do that because the x would be less than the y. And 1, 1, 1, there's only one way to do that. That's sort of y, z, y, x. It's annoying. I wish they'd labeled it x moves first. This is irksome. Okay, so now I have the values for everything involving z with a 1. What if I had z with a 2? Okay, so y could be 0, 1, or 2. X could be 0, 1, or 2, but we don't need the bottom row here. So this square here would be I of 2, 0, 0. And there's only one way to do that, just 2 z's. So one in there. And now, here I think we're finally going to get the recursion that I keep talking about. So I want I of 2, 1, 0. And that's going to be... So I of 2, 1, 0 is I of 1, 1, 0. And we added on a z. Plus I of 2, 0, 0. And we added on a y. Okay, so 1, 1, 0 is this. 2, 0, 0 is this, so we get 2. There are 2 ways, and I think that's z, y, z, and z, z, y. Alright. So now if I wanted 2, 2, 0, well, that'd be the same as doing 1, 2, 0, which is gibberish, or 2, 1, 0, which is this one over here, so that'd be 2. Okay. This is starting to make more sense now. I'm starting to understand. So now if we did 2, 1, 1, so that'd be this one right here, we could have 1, 1, 1, which is one way to do that. We could have 2, 1, 0, or 2, 0, 1. And that would be adding a y. But of course, this one here is 0. This one is the one above, 2, 1, 0, so it's 2. And 1, 1, 1, there's one way to do that, so we get a 3 here. So it looks like we're adding this way and then the same number in the previous chart. So I guess I do need the 2s and the 3s here. But they're just all zeros. So if it doesn't exist in this chart, it's a 0. So this, in theory, should be 5. And so that'd be 2, 2, 1. So we could either be adding on 1, 2, 1 coming from this chart, but that would not exist. Or 2, 1, 1, which is this 3 here. Or 2, 2, 0, which is the one above it. Okay, so now this is making sense. And this 5 comes from here. Because nothing comes from over here. And there's no way to have 1, 2 for the y's. Alright. This is working. This is working. So now, let's fill in the chart with z is 3, and then the bottom corner should give us our answer. Alright, one way to do it up here, because that's just 3 z's in a row. 3 z's and 1 y. That's the same as this number here, and 2 z's and 1 y, so that's the 2 coming from here. So there's 3 ways to do that. That's zy, zz, zz, yz, and zz, zy. Okay. All of these down here are zeros. Okay. Now, let's get 2 y's up in there. So 2 y's, we're never going to do anything with the x's. So it's going to be 3 coming from over here and we've added a y, or 2 coming from over here and we've added a z. So it should be 5. And then for 3, we can't do it with 2 z's and 3 y's because that number would be 0. So there's nothing coming from over there. So this is going to be 5. So there should be 5 ways to have 3 z's, 3 y's, and no more z's than y's on any portion reading left to right. All right. And if I wanted to, I would stop and verify one of these. Okay. Now z is 3, y is 1, and x is 1. You won't get anything coming from here. You'll get 3 ways to do this, and then 3 ways coming from this. So that'll be 6. Okay, and then 5 ways to do it, plus 6 ways to do it, plus 5 ways to do it. It should be 16 here. 16 ways to have 2 z's, 2 y's, and 2 x's. Or sorry, and 1 x. Okay, and now the 5 from here. There's no way to have had 3 y's and 1 x and have 2 z's, so nothing coming from there. So it should be a 21. The numbers are starting to grow fast enough that I think we might get like 48 or something down here. 0, 16, and this 5 from here gives me 21. 21, 21, 42, because there's a 0 coming from over here. And nothing, 42, and nothing gives me 42 as my final answer. Is that better than doing the tree diagram? I honestly can't say. But I am proud of the fact that we worked it out to sort of a more recursive method that I think would allow us to be able to answer bigger questions. Like, if we had to move everything over by 4 spaces, that would be a much bigger tree diagram, because you'd have 12 branches, and you'd have a lot more cases where you can do the x, y, and z, and I think that would get crazy. Whereas I think this method of, okay, transfer from this chart to this chart to this chart, I think that could keep going a little more reasonably. And I think that one also lends itself to having, coin number W or something like that. So, was my enumeration with the charts better than my enumeration that I abandoned with the tree diagram? I'd say at this level they're even. And that's okay, because there's the brute force tree diagram method, and then there's the sneaky recursion way, and both of them would work perfectly fine, I would say. I think there's more bookkeeping to do with the tree diagram, but I'm confident that would have worked out. Just would have taken a while. But I like the recursion way, the finding the list of instructions, and then, okay, could we add a Z to this set of instructions? Could we add a Y to this set of instructions? Could we add an X? And I think that actually, I got pretty good at filling in the chart there. Our answer is going to be C here. But I have to imagine there might be a faster way to do that, because unless you had seen recursions like this before, which I had, I wish I could remember exactly what that Fibonacci sequence question was, but you learn some of these recursion techniques, and you also had to make the connection that your tree diagram is going to give you a list of instructions, and it did take me a little while to understand how these instructions would be put together. So I think if I had to go back in time and tell myself how to do it, probably the tree diagram. It doesn't lend itself to the notepad I use here, but if I had a piece of foolscap and was writing tiny for myself on the contest, I think that would have worked just fine. I'd be interested to see if there were other solutions out there. I don't know if you guys have another one, or if Waterloo has a better solution, a better way to do it. They're sneaky. Maybe they did recursion. I really hope their answer wasn't just draw a giant tree diagram, but I'll find that out if and when I bother to look up the solutions. For now, though, we ignore question 24. That's done. Answer was C42, and we set our eyes on question number 25. And that'll be the last question. That'll finish off the Cayley quite nicely. So if you would like to, please join me in the next video for that question there.